Today in the Daily Dose, quantum mechanics. While early physicists employed mathematical formulas to explain the motion of objects, during the early decades of the 20th century, physicists began to challenge unexplained phenomena within classical physics through a subfield now known as quantum mechanics, all in a quest to understand the behavior of atomic particles at the molecular and submolecular level. Beginning in 1900, when German physicist Max Planck showed how equations composed by physicist Ludwig Boltzmann to describe the behavior of gases could also be used to identify a relationship between temperature and color within a filament light bulb, which in turn challenged principles that objects existed in a specific place at a specific time, with a new vision of how objects instead exist in a haze of probability, fluctuating between particles and waves. In 1905, Albert Einstein added to Planck's work upon the publication of his paper concerning a heuristic point of view toward the emission and transformation of light, where he envisioned light traveling not as a wave, but as some manner of energy quanta, offering insights into the behavior of 9 phenomena, including the specific colors that Planck described in his light bulb experiments. Employing Thomas Young's 1801 double-slit experiment, by way of reproducibility, electron particles are bombarded at a board with 2 slits cut through it, capturing electrons on a backscreen that pass through the slits. In such a manner, electron particles revealed themselves with 2 bright lines on the back screen, while electron waves developed interference patterns of dark and light bands, which was further validated by French physicist Louis de Broglie in 1924, when he demonstrated that electron particles could exhibit both wave-like and particle-like characteristics. During the second decade of the 20th century, Danish physicist Niels Bohr furthered the understanding of the quantum nature of atoms when he successfully showed how electrons moved around a nucleus in orbital strata, much like planets in our solar system, jumping between orbits in response to a specific amount of applied energy. Bohr's atomic model would soon be replaced by the work of German physicist Werner Heisenberg in his matrix mechanics model, while in an impressive display of parallel creation, physicist Erwin Schrödinger developed a similar theory now known as wave mechanics, revealing that both mathematically distinct approaches bore equivalent results, further proving that electrons obey a wave function that occupies orbitals rather than orbits. In 1935, Einstein teamed up with physicists Boris Podolsky and Nathan Rosen to show that 2 quantum particles could be set up so that their quantum states would correlate with one another, which allows quantum physicists to measure the state of one particle, which instantly reveals the state of its twin, giving a result called the EPR paradox that Einstein called a spooky action at a distance, while Schrödinger later coined the term entanglement theory, making quantum mechanics a subatomic blueprint of the macro world at large. And there you have it, quantum mechanics, today on the Daily Dose. If you enjoyed this short educational video, consider giving the filmmakers a YouTube super thanks from as little as $1, so that you too can feed the filmmakers who feed your brain.